just one thing. Vectors have two parts. If you're fancy, you call them components. It's basically got two things to it. One is magnitude, the other is direction. What does that mean? That means size, basically. Yeah. These two vectors look like they have the same, well, opposite directions. So they're parallel. They look like they kind of have the same size, same magnitude.
Yeah.
Yep. All right. Go with the arrow, it's plus. Against the arrow, it's minus. See how we do. What did he have me doing here? Draw a diagram to illustrate the vector addition of A plus B plus C. So A, 1, 2, 3, 4, 5, 6 right, and then 1, 2, 3 up. B is 1, 2, 3 right, and 2 down. And so all you would do is like 6 right, and then 3 up, and then 3 right, then 2 down, and then another 6 down. So something like that. Just put them end to end.
Yeah.
And that's what they look like, is it? Yeah. A, B, C, and so overall it's just that one thing from A to B to C. Yeah. All right. I have to do this stuff. So this is A. So they'll break it down to algebra. So instead of saying 6 right and 2 up, or 3 right and 2 down or something, they'll just call it A or B or C. So A might be 4 to the right. 3A would be 12 to the right. Yeah. A half A would be 1.5 to the right, that type of thing. B and minus 2B, that would be twice as long in the opposite direction. Something like that. Right, let's try this stuff. In terms of these vectors, what is P to S? And you can only travel along routes that you know.
Okay. So that needs to be, would it do, like, would you use A and C for this?
So you have to use A and C. So basically P to S is equal to P to Q plus Q to S. That's one route you could take.
Okay.
And so what would that be?
Would that be A and C?
It would be well, plus C. So this one is C. This
would
one
be minus A.
Yeah, you're going against the arrow, and so that one's minus A. That's it. Part B.
But how come like C is positive and it's going in the same direction as A?
It's because we Q to P is A, P to Q is minus A.
Oh, okay.
So we're starting from P. We have to go P to Q, then Q to S.
Okay.
So against the arrow of A, and then with the arrow of C.
Okay.
Right, part B. R to P.
So it'd be P to Q again, and then Q to R.
R to P. Hang on, we're starting from R. We have to get to P. So what's the route we take, sorry?
R to P, and then...
So we're trying to go like from R to P. Problem is R to S is blank and S to P is blank. So we have to take a different route.
Okay. Could we use...
We can only travel along... We can only travel along lines that have like that we know the vectors for.
Oh, so we can do R to S.
We don't have a vector for that line. There's no like vector there.
Okay.
How else can we get from R to P along like known vector routes?
A and B.
Okay, so what from R where next?
To Q and then Q to P.
Yeah, that'll work. Okay, what are those?
Minus B and then A.
Minus B plus A. Great, you're getting it. C. P to T.
Okay. So could you do P to Q, Q to R, R to T?
Yeah. What is that?
Minus A, B, D.
What goes in between minus A
Plus.
and B? Yes, plus. Without that, you'd assume times or something.
Yeah.
And D.
Okay. So could you do T to R,
Yeah.
R to Q, Q to S,
Yeah.
which would be minus D plus minus B plus C.
Yeah. Minus B
Plus C.
plus C. Yeah. So it's like minus D minus B plus C.
Yeah.
And that is R to Q, Q to S. Great. And so after a while, when you get good with these, you don't have to put in the big letters like T to S. You won't, or let's say P to T. You won't have to say P to Q, Q to R to T. You'll just kind of see it's minus A plus B plus D.
Yeah.
But when the questions get more difficult, it does help to go back to just big letters. Just work out a route that works first, and then just sub them in. All right. Any questions there?
No.
You're gonna find these tricky. I'll tell you that.
Okay.
They're not easy. Okay, let's try this. A to C. This is a parallelogram.
Okay. Wouldn't AC just be A plus B?
Yes. So, you could say, let's say it's A to B plus B to C, and so you have that one is A. This one is blank, but because it's a
That's
parallelogram,
yeah.
we know it's the same length and same direction. So
Yeah.
same magnitude, same direction. Or you could go the other way. You could go B plus A, same thing.
Yeah.
Yep, great. Hold on before we start doing wacky stuff. Oh, it's all going to get wacky, isn't it? Yep. All right. Any idea how we show that these two vectors are parallel? Fully factorize.
So could you factorize out 3
From the
The
second
6
one,
and
you
9
could. Yeah,
of the second one?
you can factorize out 3 from the second one.
So it'd be 3 outside the brackets, 3A plus 4B.
Yeah, and then first one.
Factorize out 2.
Mm-hmm.
Give you 2 and then 3A plus 4B. The
So,
same.
what do you notice?
That 3A plus 4B in both brackets.
Yes, so it's the same vector, just multiplied by a different what's called scalar, which is just a normal number. And so it's the same direction, just a bit longer, so therefore it's parallel. I don't really like how they laid this out. I'm just going to call this first one A to B.
Yeah.
I'm going to call this second one C to D.
Yeah.
And I would say something like C to D is like 3/2 bigger than A to B or something like that.
Yeah.
Don't know how you'd say it. Yeah, so 9A plus 12B is 3/2 of 6A. Oh, show that question, therefore parallel.
Yeah.
All right. Hang on, before we do. You see, they made me do this parallel nonsense. I shouldn't be doing this parallel nonsense. This is where the money's at. Look at this. Yeah. Okay. This is what we need to be doing. Hang on. I need to improve this. Okay, let's try this one.
Okay. So, well, we don't know which direction any of the like sides are going in.
Let me see. I think we do. They just didn't put it on the thing. A to B is A. So this is
It's
the
A
vector.
to B, right?
Yeah.
Just going down.
So it's in that direction. Then A to C. That one is B. Yeah.
So could you say B to A to C for the first one?
Yep.
Which is minus A plus B.
Yeah. Okay. How about part B?
Okay. Could you say C to A and then
Simpler than that. What is A to B?
B, so it'd be half A to B.
Yes, it's a half of A to B. What is
So
A
it's
to B?
half of A.
So it's just a half of A.
Yeah.
Part C.
Would that just be... But the ratio could be written as a fraction, right?
Yeah.
So would it be like 2 over 3?
How many parts in total?
5 parts.
And so that's like 3/5 and 2/5.
Oh. So it'd be written as 3/5 AC.
Yes.
So it'd be 3/5 B.
Yep. Very good. Very good. And then part D.
There would be minus 3/5 B.
Other way. Start
Other.
at P, go to Q.
Oh yeah. It would be a half, no, minus a half A plus 3/5 Q.
And what is A to Q?
A to Q is 3/5.
3/5 of what?
Oh, B, sorry.
Yep. That's it. Let's see. What subjects are you doing in school?
All the sciences and this. Maths. Yeah.
And vectors comes up. You're
In
doing.
physics.
Yeah. You're very good. I thought you'd have more trouble with this. Let's see. All right. Exam time. Let's give this a go. P to Q is A. P to R is B. All right. Just saying easy. All right. Let's give this a go.
Okay. So is y the hypotenuse, like all of it?
Y is what is this? It's in a ratio. Y, it's not quite the midpoint.
Okay. It's 2/3.
Nope. How many parts in total?
Oh yeah, sorry, 2/5.
Yep.
Other side's 3/2. 3/5, sorry.
Mm-hmm.
And PQ is in the ratio of 1/4
Yep.
and 3/4.
Mm-hmm.
Okay. So it wants yx. So could you say it wants it from y to x?
And so, like, for these types of questions, when it starts getting harder, then it does help to kind of work out your journey and all that.
So could you go from x to r first? Oh no, q to y. Would that be right?
Start from Y, stop at X. So
Y to r then.
so you could
But
do
you
what?
can't. There's no vector, is there?
Well, we can see. So let's say we can figure it out. So let's say Y to Q. Oh, hang on. Yeah, maybe you're on. Let's do Y to Q.
Okay.
And plus Q to X, because it's only got 2 steps instead of 3. Let's see. So Y to Q, what fraction of the total is that?
So it would be 2/5 y to q.
So Y to Q is 2/5 of what?
2/5 of qr or rq.
RQ, yeah. And then how about the other one?
Rq. The other one would be 3/4 of pq.
Other direction?
Oh, minus 3/4 pq. Oh no, qr.
Yeah, let's just go QR. Okay, so it's 2/5 of RQ. What is RQ?
Wait, is it 3/4 of qr? Or is it qp?
Sorry, that one is RQ. That one's QP, sorry, yeah.
Yeah.
QP.
Wouldn't qp be minus?
We'll get there.
Okay.
It's just 3/5 of whatever QP is.
Okay.
Okay, so 2/5 of R to Q. What is R to Q?
R to q is 5.
In terms of vectors A and B.
R to q wouldn't be either. It would be like c, even though it's not there.
So travel along vector lines that we know. A and B vector lines.
So you want me to get R to q?
Yeah.
So to be just b plus. Could you just do?
So what routes can you take from R to Q along vector lines?
Oh. Could you just do R with 3/5 ry?
Yeah, but we've it's true. It's going to be the same stuff, but along known vector lines. So R to Q, you could go R to P and then P to Q. So what is R to P and P to Q?
R to p is b. P to q is just a.
And R to P is against the arrow?
So it'd be minus b.
Yes. So Y to q is 2/5 of r to q, and so
Yeah.
r to q is r to p, p to q, and so it's 2/5 of that, 2/5 of minus b plus a. So we're traveling along b and a vectors. Okay, so we got r to q. How about p to q? Sorry, q to p.
Okay.
How can we get from q to p, or what is q to p?
Isn't Q to P just A?
Yep,
Minus A.
minus a. So that's going to be minus 3/4 of a. Okay, and so now we have to simplify.
Okay. Wait, which ones are we simplifying? The bottom two?
Yeah, so this I'd fully expand bracket.
Okay. So would it just be 2/5 minus B?
Minus 2/5b, minus 2/5 b.
5B plus 2/5A
Yeah,
minus 3/4A. And then you can simplify those two.
Yep.
So it'd be 2/5 minus quarter. So it'd be minus 2/5B minus 7/20A.
let's hope. There we go. There we go. Okay, so how do we do this? So y to x, we also could have, so y to x, we decided to go y to q, q to x.
Yeah.
We could have gone y to r, r to p, p to x, but it's got 3 journeys instead of just 2.
Yeah.
Y to q is 2/5 of r to q.
Yeah.
R to q is r to p plus p to q. And so slowly but surely, we're breaking it down to roots that we know.
Yeah.
And then you expand and fully simplify. Any questions about that?
Nope.
Trickety. All right, let me see this one. Prove that it's parallel. Not yet. There's that is. They do want this whole parallel thing, don't they? Prove that that's. Oh, I'd love another question of this. Why? No. Oh. I'm not gonna find one, am I? I need to get extra questions for this thing. Alright, we'll prove this parallel stuff. We said we would. Alright, let's try this parallel stuff.
Okay.
I'm going to make a judgment call and say it's going to be easier to do some higher market question. Okay, let's give this a go. I might come back to that one. A to B is A.
Okay. B to C is B.
B to C is B.
Okay. And D and E are the midpoints, so we know that.
Mm-hmm.
So could you say like A to half A to B is D? A half AB.
Yeah, so A to D is a half of A to B. And these ones are like simpler vectors, so you'll get away with just going straight into it, I think.
Yeah. And then would you need to go to from B to C to E? So B to E is half BC.
Yeah. And so you have, I would just find what is the vector A to C, and then what is the vector D to E.
So A to C would be A plus B.
Yep.
And D to E would be half A plus a half E. Oh no, half B. Sorry.
Yeah. We want to show that they're parallel.
Did you factorize?
Yep.
Okay. So would it be would you factorize out a half?
Yep.
So it'd be a half brackets A plus B. And then for the other one you could factorize out 1.
Same thing. Just A plus
Yeah.
B. And so what is the relationship between AC and DE?
Therefore AC and DE are parallel to each other.
Slow down, cowboy. Something in the middle. You could say something like D to E is half of A to C. Therefore, they're parallel.
Yeah.
So just spell it out. Show that like DE is some multiple of AC. Or you could say AC is 2 times D to E.
Yeah.
Therefore, they're parallel because it's the same direction. It's just multiplied by a scalar.
How come AC is a half AC and it's the same as DE?
It's because so AC is double DE, so you'd have to multiply it by a half to make them equal.
Oh, okay, yeah.
It's always it always feels backwards. The other way you could write it is 2 times DE is AC. So like AC is double DE, whichever way you want to.
Yeah.
So A plus B, a half A plus B, a half A to C. Yeah. So the two lines are parallel as one vector is a scalar multiple of the other. Great. Oh, I like the diagrams. What is this stuff? It's a trapezium. I'm gonna sketch it. Okay, trapezium looks something like that.
Yeah.
FG is parallel to EH. FG is parallel to EH. So I don't know which is the longer side or whatever.
Yeah.
M is the midpoint of E to F. N is the midpoint of G to H. Okay. E to H is A. E to F is B. H to G is C. They don't make my life easy. Okay, we want M to N.
Okay. We want M to M. N, did you say? Yeah.
Yeah, M to N.
So for the first part, would you say ME equals minus a half EF?
ME. Yeah. Let's see. So let's just work out this thing. M to N. So let's just say M to E and then
M to N, MM equals ME plus A
yeah.
plus HN.
Yeah. Okay. So sub in what you know.
Okay. So MN equals minus a half EF or minus a half B.
Yeah, it might half B.
Add A. Add a half HG.
And what is HG?
C.
Yeah, this can be real difficult though because they want only A, no B, no C.
Yeah.
Let's think about this. So E to H, and they want a K in there as well. So we're told F to G is the same as K times E to H. Let's take the other route or something.
Okay.
Is that how you do this? Or maybe. So okay, now let's just take the other route.
Okay.
M
So
to
to
N.
go M to N equals half. You say EF FG, and then
So
G.
yeah, M to F, F to G, and then G to N.
Okay.
What is that?
So that'd be half B plus KEH minus a half C.
And what is E to H?
E to H is just A.
So I'll just write that as KA.
Okay.
KA plus, minus a half C.
Yeah.
Oh gosh. So that's two different ways of writing the same thing. Do we now make these equal to each other or something? So if these were equal to each other, it would be minus a half B plus A plus a half C equals a half B plus KA minus a half C. We're trying to get MN. Oh, God, what is this? Now, I have a better idea. Add the two together.
Okay.
So 2MN. So if that's 1, that's 2. We add the 2 together. So 2MN equals what?
Equals a half. Minus a half B plus A plus a half C. And then would you add a half B plus KA minus a half C?
Yeah. What is minus a half B plus a half B?
Where they cancel out to make just B, right? Or do they?
Just 0. Just nothing.
0.
What is a half C plus minus a half C?
They cancel out as well. So you get left with KA plus A.
Yeah. KA plus A. They want just A. So factorize out A. What is that?
That is A brackets K plus 1.
Yeah. Plus 1. So that's 2mn. So what would 1mn be?
You need to divide by 2 both sides.
And what would you get?
You'd get K plus 1 over 2.
K plus 1. Yep. And in the question they wrote it as 1 plus K.
Yeah.
1 plus K over 2 A. They put the A at the end. Yeah, God help you if a question like this comes up. So it's a trapezium. So we had to take two different routes and then do them simultaneously. Like add them and simplify. Whew. So m to n is that, m to n is that. Adding them gives you that. Fair enough. Oh, hence or otherwise explain why mn is parallel to EH. EH. Why is mn parallel to EH?
Because
what is ETH?
what is EH?
Mm-hmm.
EH is A.
And so this A you can replace with EH.
Yeah.
So basically m to n is the same as 1 plus k over 2 of EH. And k is just a number. And so this is just like mn is just a scalar multiple of e to h. It's just like e to h times by some number.
Yeah.
Therefore parallel. How about f to g?
F to G is KA.
Yes, f to g is ka. And so same idea.
Yeah.
M to n is 1 plus k over 2 times ka. So that's a scalar multiple. Yeah, they're all scalar multiples of a. So they're all parallel to each other. All right. Any questions about that one?
Nope.
Let's never speak of that one again. Okay. X a half or tick?
Probably between a tick and a half.
Oh, I don't like vectors. All right, let's see. Column notation. So now they're kind of bringing in the numbers. So this vector, 3 to the right, 4 up. Sure. Let's give this a go. So A is 2 right, 6 up. What is a third of A?
A third of A. So it would just be 2 over 3 over 2.
Yeah, and you don't say over for vectors because they're not fractions. It's just 2/3 and 2. Yeah, 2/3 to the right, 2 up. All right, how about part B?
Would it just be 2? When it says A plus B, does it happen to both of them? So would it be 2 over 2?
So it's 2 to the right, 6 up, plus 3 to the right, 1 down.
Oh, okay, I got it now. So would it just be 6 over 5? Or 6, 5?
How do you get 6?
Oh, sorry, 5, 5.
Yep. Yeah, so 2 to the right, plus 3 to the right, 5 to the right. 6 up, 1 down, 5 up. Part C.
So A would become 4, 12,
Mm-hmm.
and B would become 9, minus 3.
Yeah.
And that becomes minus 5. And then would those two just add 12 and 3?
Mm-hmm.
So it become 15.
I think that's it. Let's check. Yeah, minus 5, 15. 5, 5. And then 2/3, 2. Great. Any questions about that one?
No.
Alright. Okay, so this is I and J notation. I is 1 unit to the right, J is 1 unit up. It's a bit like X and Y, that type of thing, but for vectors. So this one here, 5, 2 is written as 5I plus 2J.
Yeah.
This is a different way of writing it. Alright, how about this?
So it'll just be 1.5i.
Yeah.
Yeah.
Oh, that's right, it's 3 over 2I.
Would that be right for the first one? Or minus 4j?
Something else?
Oh,
It was 4 down. Half A.
oh, 2.
2J, yep, half of both of them. Part B.
Should be 3i minus 4j plus 2i minus, no, 2i plus 7j.
Yeah.
That would become 5a,
5I.
5i, sorry. And then plus 4j. No, 3j, sorry.
Yep. And C.
Okay. So C would, so A would become 9i minus 12j.
Yeah.
And B would become 4i plus 14j.
Yeah.
And then that would become taking them away, it would become 5i.
Mm-hmm.
And then plus 2j, right?
Nope. So this top one up here, expand these brackets, what do you get?
You get 9i minus 12j. And then expanding the second one, it would be minus 4i minus 14j.
Yeah. Minus 14J. And so simplify.
That would become 5i. So would it just become minus 12j minus minus? No, would it be minus minus or just minus 14?
Just minus 14.
So it'd become 26j.
Yeah, minus 26J. And so because in here you have like minus both of them, so that's the bit that everyone loses. So I wouldn't expand the first. I just write it in brackets because that's the stuff you're already good at. Grand. Okay, I and J. Right. How would you represent this thing?
Could you draw a triangle?
Yeah, 1 second. 2A minus. This one's not bad. I just want to do this one first.
Okay. So it'd just be 7i, I think.
Yeah, bum. So, write it out. What is the working out?
I got 2 brackets 5i plus 2j minus 3i minus 4j.
I see. So minus, and that one is in a bracket, 3i minus 4j. Might not be the best example. So subtract the bracket, it's like you expand it by -1.
Okay. Oh, so you still need to put that one in brackets as well.
Yeah, it's minus all of b.
Okay. Right. So would the second bracket become minus 3i plus 4j?
Yeah.
Which gives you 7i plus 8j.
Yeah.
Oh no. Yeah. Is that right?
So, yeah.
Yeah.
7i plus 8j. That's not the best example though. Not exactly what I wanted. Find b to c. Oh, yay. They don't mess around. Let's see, 2b. That's not really. Maybe this will work. 2a. I think this will work. So how would you start this one?
Okay. When you started with would you need to write it out as for the first 2a plus 5b, 2 brackets minus 2i plus 7j, close brackets, plus, and then brackets 5, no, sorry, 5 brackets, the 3i minus 2j. And then for the separate other one, you'd write out as 2 brackets 2i minus 2j, close brackets, minus 1 brackets minus I minus 6j.
Yeah. And you're going to be fine for the rest of that.
Yeah.
That's the difficult bit. Let's see. All right, so now I can go back. I believe. Okay, yeah, sorry, this one. So you said as a triangle.
Okay. So we know that minus 3i would be going to the left because that's backwards.
Yeah.
And we know that j is positive and it's going to the right.
Nope. Positive I goes to the right.
Oh, j is going up then.
Yeah. So I think it can be like that.
Yeah.
And so overall, it's going to look like that.
Yeah.
Write this as a column vector.
It would be written out as minus 3i j, 1j.
No j.
Just minus 3 and 1.
Yeah, and 1. And let's see, so triangle. I suppose you could do it as just 3 and 1.
Yeah.
I wonder what way they're going to do this. Okay, they did it the way I did. Minus 3i and then 1j. And so this line is minus 3i plus j. I suppose I can put that in. So that line is minus 3i plus j. Grand. One sec. I thought I skipped something. No. Okay. Let's see. This thing. A plus B plus C. You'll be fine.
Yeah.
Let's see. All right. This is a bit weird. How do we do this?
Okay. Okay. Would you draw out the triangle first with that?
Definitely. I think that's the... Once you draw the triangle, it becomes much easier.
So we know that AB is going left and also up, right?
Oh, that's a good point. Yeah, I wouldn't have thought of that.
And AC is going to the right and going down by a bit.
Yeah. A to C is right and down, yeah. And so we want A to B. Oh, sorry, we want B to C. So that was A. That was B. That was C.
Yeah.
Okay.
Okay. So could you write it out as minus BA?
Plus 7. I would just travel along vector routes that you know. We want B to C. So how can you get from B to C?
We can go from B to A then to C.
Yeah, B to A plus A to C.
So it'd be minus BA.
Depends what you mean by that. Minus BA is just AB. It's not minus BA, it's just BA. But
You're trying to travel to C, aren't you? From B to C.
uh,
And the vector line's going in the direction AB, so it wouldn't be a negative, wouldn't it?
negative of the I and J stuff.
Oh. So it'd be B to A and then A to C.
Yeah.
So it'd be minus I plus 7J.
So it would be, you know, this one. So A to B
Yeah.
is minus 8I plus 7J. What is B to A?
B to A would be positive then. Or did it be 8I plus 7J? Or minus 7J?
Correct. So it's like the negative of that because it's going against the arrow.
Yeah.
Yeah. And so that's 8I minus 7J. And how about the other one?
Other one would be minus 11I plus J.
This one's going with the arrow.
Oh, so it just stays the same then.
Yeah.
So it gives you 19I minus 8J.
Yep. That should be it. So just travel along routes you know. Yep. And watch out for the arrows. Draw the diagram because with the diagram you can see what way the arrow is going.
Yeah.
I need this diagram. Yeah. Hang on. Let's see. Oh, this is much easier. Well, it's just because it has a diagram already, I suppose. Okay, how about this?
Okay. So could you do minus 4i minus 3j?
Maybe. Go on.
Add 5i plus 2j.
That's what it might be. So that's A to B. So we want B to C. So you have to do that one. Yep, that'll be it. I think it's, what is that? Sorry, 1i
Yep.
minus 1j or something. I minus j.
Yeah.
Hey, got it. Got it. I'm happy. No more. What is this? A is this. B is this. Alright, how do we do this?
Okay.
Let's see. Nah, we'll leave it. We'll leave it for next time. You can try it as homework. Just have to. Well, we'll do our best. Yeah. So far with this vector stuff, we got most of it. There's more. What do you give yourself?
Probably a tick for now.
Yeah, it's good. Yeah. How's that for you, Adam?
That was great.
Grand. If you talk to that Karma girl, you can tell her if she wants a Christmas card too, she can send me her address.
Yeah.
Doesn't have to though. I love Christmas cards though.
Yeah.
Any questions for me in general?
Nope.
All right, and so we did all our days and stuff